I don't know why I missed. So yesterday we have spoken about the concept of inheritance and all the access modifiers, and we did discuss about the scope of public, private, protected, and default, and we saw the concept of method overloading and constructor overloading as well. In this part, we did also discuss about the accessing of superclass constructor. How do you instantiate? How do you inherit a class which is having a constructor which takes parameters? We discussed about that also. This one, if you have a constructor which takes arguments, how to instantiate them, right? So we spoke about that. I hope you have no questions about that. Let me start my Eclipse. So this is where we concluded our session. All right. Now the concept we discussed also the method overriding, right? What is overriding? The method overriding, which allows you to define method. For example, in our person class, we had this method already called talk method. You had this method talk, but what have you done in student? We had overridden that. In student, we had overridden that. We had a different method, the same method with a different implementation, overriding. So this concept of overriding is actually depicting the behavior, polymorphic behavior of Java. All right. What is polymorphism by definition? It means that your objects can exhibit more than one type, more than one behavior. In fact, your objects can expose more than one behavior. It means that one object can behave in more than one way, and that means in this example, when you have object. Now let me come with one example here. We have already seen the contents of person class. Person class, if you just want, we can have a look at it again, has method called talk and walk, and talking and walking is described here. And in student, what we are doing, we are extending the person class and overriding the talk method. Now, if you just happen to understand, I'll do one thing. I'll create the student object with person reference, person P. Now this is a matter of convention that your superclass object can refer to superclass reference can refer to subclass object, because when you say something is a subclass, you want to say that it is a type of that class. It is similar to that class. Every student has to be a person because it is extending from student class. It is extending from person class essentially. So that relation always exists. Every student is a person. So student objects can be referred using person reference. Just like anything is, it's an object. All right. Similarly, every student object extends this from this person class can be called as a person itself. You understand the relation in real world. Whenever you say a person, it is a student. Sorry, a student is a person because it is inheriting from that class. So this is the matter of convention that you can use a reference of a superclass to refer objects of subclass. You can do that because there is a parent-child relation between these two things. All right, and you can call methods like p dot talk, right, and p dot walk. This is actually calling the methods of student object because the object is of student reference, but reference of person is used. Student object referring with person. But one difference what you will notice here is you will not be able to call p dot study, because study is not defined in your subclass, sorry, in your superclass. Study is not defined in the superclass and you are using superclass reference. For that reason you cannot call this method. Even though the method is there in the object, but you still cannot call it because the reference what you are using is superclass reference. And that's what I am pointing it in this slide, in the next slide maybe, yeah, that savings can access own members as well as all the inherited members. So whenever you are creating an object of subclass with the subclass reference, you can access all the members as well as the inherited members, the members of its own class as well as members of the inherited class. And here what I am doing, I am having an object of savings class but with the reference of account class, and this will not allow me to access the method which are available in the superclass, sorry, in the subclass. Can access methods which are inherited or overridden methods. If you have overridden some methods, you can access those, but you cannot access the subclass methods directly. If I run this without the study, let me run this. You see talk method of object per student has been called because I see talking better. Talk of student is called. There is no walk method in student. You are still calling the walk method of person. Walking. Inherited method, I mean to say. So you will be able to use all the inherited methods here, all those which are inherited, as well as the overridden, but not the one which is defined in this class. Now if you want to use, let's assume that you are using the person reference to refer to student object. Now you want to convert back to student reference. Now you want to use the student reference again. So for that purpose there is a concept of object casting. So what you will do is you will define a student reference, student S equals to cast it student P. So what are you doing here? You are creating a reference for this object reference P with the student object reference. You are casting it again. You are making the reference of P to S, and now you can use this S reference to talk as well as to walk as well as to study. This is called as casting of objects. You are doing a typecasting and you are converting your class from the person class, you are making it to the student class again. So if I run this, I'll see, there you see these are called by the second object reference. Talking better, working and studying. Alright. Explicitly typecasting is mandatory to access the subclass methods again. Now when you do this, you can access own members as well as all the inherited members It might throw random exception if the object is not of type saving. Yeah. If you are casting an object which is not of that type, it might throw error. So for that purpose, you have to, there is a operator called as instance of operator, which you can use to check if an object is of the type of some class. In this case, account A or account ACCT is instance of savings. So if it is instance of saving, it will return true, and this will do the type casting. If it is not the instance of savings, it will not do that, and it will not do the casting as well. So the polymorphic behavior in Java is exposed by uh, these two methods, like method overriding and method overloading. We have seen method overloading. This is the overriding. This concept of method overriding provides you the dynamic polymorphism, right? The concept of method overriding provides a dynamic polymorphism. Let me remove this. This is clear. In fact, let me have that reference. I'll just remove the methods. S dot talk. So only one object. I mean, we have one object here, right? One object student of these values, but I can call them by two references. If I call it by P reference, it is saying it is talking better. All right. Now what I do is I'll not do this casting. I'll just declare the reference of P here. P equals to new student. Fine. And over here I'll say P equals to new person. P equals to new person, and if I say P dot talk, it will call the talk method of person, and if I say walk, it will call the walk method. Understand this? One object, one reference, okay, but two objects, and I'll see two different behaviors. There you see. If I see P dot talk, it is saying Ramu talking, which is of the person class. It is not of the student class. This is of the person class. And when I use this P and instantiate this student object, I'm getting Hari talking better. So that behavior, that polymorphic behavior of this object reference is a dynamic polymorphism. This is the concept of dynamic polymorphism, where you are seeing that the object is behaving in more than one form, right? And what is static polymorphism? Again, the same definition. Polymorphism means the concept of the object exposing more than one behavior, right? And the reason why this is called as dynamic is this binding, what happens of method, the method binding for this method, for this object reference P dot talk here and P dot talk here, this binding happens at the runtime, and that's why we call it as dynamic polymorphism. And whereas the concept of method overloading, what we have seen earlier in our example couple of days back, the overloading concept actually exposes the static polymorphism. This also does the same thing. I mean, the behavioral is the same. Uh, Alright, I was losing the audio, I guess. So this method add takes different arguments and accordingly it behaves differently. If I pass two integers, it will call the first add method. If I pass three integers, it is calling the second add method. If you remember the example earlier, what we have done, this is the concept of static polymorphism. The reason being this is called as static is all the method binding which is happening here is happening at the compile time. It is happening at the compile time, and for that reason this is static binding or compile time binding. If you just want to want this to be clear, you can say this is an example of compile time binding. Or static. Alright. So what is polymorphism? An instance method in a subclass with the same signature as an instance method in the superclass is called overriding. Method name must be same. Parameters, type, number and order must be same. It should be the whole signature. The signature should be same. It shouldn't vary in the signature. So if the method signature is same, you call that overriding. And when you are overriding, you are actually doing polymorphism. Okay. In this example, class account has public boolean withdraw amount, and in savings account you are extending account, you have public boolean withdraw amount, and you are overriding the method. Here you are checking, you are not checking anything here. Here it is checking if the get balance is less than minimum balance. Return true, else return false. So this will do some check. The same method signature is used, but implementation is different. So in this example, if you want to see, you just look at the method display in account class. It has print line, account number, name and balance. And in case of savings account, it has display, it is calling super.display, and it is simply displaying the minimum balance. The overridden display method, addition to the information provided before, additional data about saving is included to the output. That's it. Now this keyword super is also being displayed here. If you want to call the superclass object members, maybe methods or variables, if you want to refer to superclass references, you can use super keyword. Just like this keyword is used to access members of current class, super keyword is used to access members of the superclass. And you can use this super.display to call the display method of the superclass. For example, we'll see that in case of our person demo. I want to have a behavior where I want to say the person talking and student talking better. I still want to call this person talking here. I want to execute the person talking. I'll say super.talk. So when I say super.talk, this will call the superclass method talk, and superclass method talk will be executed, and it will print this line saying name talking, and after that this will be displayed, talking better. So let me just execute that with student object. There you see, it is saying hurry talking and hurry talking better. So you are adding some new behavior, you are extending that. So in the overridden method, you can call the superclass method also. That is just by using this keyword super. Alright, I hope this makes sense. So these are the essential three pillars of object-oriented concepts. We have discussed about inheritance, we have discussed about polymorphism, we have discussed about the benefits of these two things, and we have discussed about the object-oriented principles, the fundamental principles, inheritance, encapsulation, and what was that? Inheritance, encapsulation, and you have encapsulation, polymorphism. All right. So this actually, gets to a brief conclusion on the object-oriented concepts, like what is instance method, what is instance variable, what is polymorphism, what is abstraction, what is encapsulation. All right. So these things we were discussing since last 3 sessions. Okay. I hope these concepts are clear. These are fundamental concepts for Java. We are in a stage now where we have discussed all the important stuff related to object-oriented programming paradigms: inheritance, encapsulation, abstraction, and polymorphism. Now we are at a stage where we will discuss about what static thing is. All right. So far, let me have. Okay. I'll do one thing. I'll just get a new presentation. So far, the concepts what we've discussed. Let me just summarize them very briefly here, so that it makes very much clear to us. We have discussed about what class is about, and we discussed that class will have a name and class will have instance variables and it will have instance methods. Now why do we call it as instance? Because they are part of every object. Okay? You define these things in your class. This is your name. These are your instance variables. You define these things in your class, and based on this class definition, you can have multiple objects. Fine. And every object will have copy of its own variable. In our examples, we have seen the name and age values are there for every object. All right. These are instance variables. And what are instance methods? Instance methods are methods which execute or which are executed on that object, and it will modify that object's behavior. It will expose that object's behavior. And why are they called as instance? Because every object is having its own copy of those data, and every instance method will operate on that object only. When you call it instance method of talk, we did see that the the specific object talk method is called. It is specific to object, so that's why we call those as object oriented instance related methods, or instance means object. For simple, you can say these as object variables and object methods, or instance variables, instance methods. Now there comes a discussion on the concept of static members. So far we have seen instance members, now we have static members. Static members are part of the class. Okay, they are class variables, class methods, and they are just called as static because they are part of the class. They are not part of any object. For example, let me come up with an example for that. In my class person, I want to maintain the count of person objects which are created. Simple requirement is I just want to maintain the count of the number of objects created of this person. Alright, and this count I'll take it as a variable. Let's assume that I am taking it as a private int count. Fine, let's assume. And what I want to do is, whenever the object is created, I want to, every object, whenever object is created, I want to increment that number, count plus plus. Fine. And I want to have a method which returns me that count. Public int get count, return count. So whenever object is instantiated, whenever any object is instantiated of this person class, it will increment this method, because whenever object is instantiated, I will call this constructor, right? And when the constructor is called, it will do a plus plus and it will return count. Fine. So here I have one object created here. For the demo purpose, I'll say I'll do p dot get count, and I'll display that value simply. Alright, fair enough. I'm just displaying that. Let me run this. It will say 1. Fine. If I create another object, person p1 equals to new person, right. And on p1, if I call get count, and again I'll display that. Alright, let me run this. I'll get again 1, because whenever object creates, whenever object is getting created, this variable is also getting created, and every object is having its own copy of that variable, and every object is returning its own data. Every object is returning its own count, because count is also part of object here. This will give 1, this will give 1, okay, this will also give 1, but that's not what I wanted. I wanted to have a count which actually counts the number of objects which are getting created. So obviously I cannot do that in this instance variable. I cannot do that by having an instance variable. Alright, for that purpose we will have to have a static variable. I'll define this as a static now. Alright, so every object, whenever object is created, I will do a plus plus, I'll do an increment, and I'll get that by saying get count. Fine. Now if I create one object and get count, I'll get 1. if I create another object and call get count, I'll get 2. I'll say if I create another object p2 and I'll say p2 dot get count. So there you see I'll get 1, 2 and 3. The reason being is this value is not owned by any object, and hence no object is returning that data. But whenever I instantiate an object, the static value which is in the class is getting initialized, and that value is getting populated, and that is being displayed. So whenever I call the method get count, I will get the static variable value. So to understand it like this, my class will have some static elements also, but the static is owned by the object, the class itself. Members, you can have static data, that is static variable, or you can have static methods also. You can have static members, means static variables, and static methods. Fine. And this value now, the person count is maintained in the class. Now it is 4, because I have 4 objects in this example. I can have the value of that static field as 4. So this is about static members in your class. Static can be a class member, a class method, and a block. What are blocks? We will see that later. Static member can be called directly using the class name. Now have a look at this. The reason for having static is, first of all, you want to have something in the class, and if you have static members, you can use them. Now it is highly possible that whenever you are accessing a static data, your method can also be static. Okay, your method can also be static, and when you're calling that, you can call by object reference also. Every object can access those static data because they are part of the class. Objects can access them, but object will not own it. Every object can access that thing, but it will not own it. It will not have its own copy, but rather the main copy is in the class itself. The copy of the static data is in the class, and you can still view them from your objects. So objects can return that value to you. If you want to say p.getCount, you will get it. If you want to say p1.getCount, you will get the same value. If you say p2.getCount, you will get the same value which is there. If I display this from here after initializing, if I display it after initializing this, alright, if I say p1.getCount, p2.getCount, or p3.getCount, I'm still getting the same value. So for that reason, it is a convention that you will not access your static members by using the object reference, but rather you will use the class reference. You will say person.getCount. Alright. So you will use the class reference for referring to static members. Though you can use object reference also, but conventionally you do a reference using class, because there might be cases where your object is not available and you want to still access your static members. Object is not available and you still want to access your static members. In that kind of situations, it is understood that you don't have object and you want to access the class members. Quite possible. For that reason, you will use the class reference for referring to static members. Static members can be called directly using the class name. You don't want to have the object reference. A local variable cannot be static because it is local to a method. It cannot be static. Static is part of the class. Right? If you want to have a variable that are common to all objects, that is accomplished with a static modifier, static int counter. Alright. Static modifier in combination with final modifier is also used to define constants. Generally, in your examples, when you define constants, it is possible that you will define it using a static as well as a final value. Well, final because it is a final. You will use final modifier because it is a constant, and static because you want to have only one object, only one copy of that value. Alright, and you can have static methods also which have the static modifier in their declaration, and they should be invoked with the class name. You will invoke static methods using the class name. A common use of static methods is to access static fields. Static methods can access static fields. In our example, we have given the same thing. We have a static method called getCount. If you remember now the discussion what we had initially and why our main methods are static. The main method is static because it has to be called before any object is created, right? The main method has to be called before any object is created. But if it is a non-static method, you cannot call the method without having the object. Now you can call only so far we have seen methods which are being called by having the object reference, right? If you don't have this P, if you don't have this object, you cannot call the talk method. Let's assume I remove this. I cannot call talk method because I need object reference. But in case of statics, you can do that because you will use class reference. Now let me show you this, that this person dot get count, what I am calling, I don't even need any objects created. I can simply call it without having any object. If I delete these things, if I delete this as well, I can simply call person dot get count and it gives me the value. No objects are created, it's giving 0. That's fine. But what I want to show here is I can call static methods without having the object also. So for that purpose itself, main method is also static because main method is responsible for initializing your application. It is responsible for starting the flow, and it should be called even if there is no object created. In fact, it is called once the JVM is finding the class. For that reason, it is public. It is public because it has to be visible anywhere, that we know that, and it is static because it has to be called without having the object reference. It is void because it doesn't return anything. Fine, and the name is main. It's again the main thing. And it takes string arguments as command line arguments. We discussed about that command line arguments as well earlier, as to what it is used for when we discussed about the concept of arrays. So this is the static keyword. Static methods. If a subclass defines a static method with the same signature as the static method in superclass, the method in the superclass hides the one in the subclass hides the one in the superclass. What it means is if you have the same signature of the method which is static in your subclass also, so the superclass static method is hidden. This is method hiding. Static blocks can also be used to initialize static member of a class, as JVM executes this automatically before the main method. Now you can have some static blocks also in your classes which will be called whenever the main method is called. Before calling the main method, you can call these static blocks. Alright. So One last note about these final keyword. There is a keyword in Java called final. We discussed it yesterday as well when we discussed the concept of inheritance. We saw that this final keyword can be used in front of classes to prevent inheritance. So the use of final keyword in a method is to indicate that method cannot be overridden by subclass. Alright. Let me show that. If I have the method called talk as final, right? If I save it, I cannot override the method. Final methods cannot be overridden. Alright, so that is one thing about this. If you declare some or you can declare some or all of the methods of a class as final. It's up to you. You can make methods final if you want to prevent overriding. Okay. The java.lang.object does this. A number of its methods are final. You might wish to make method final if it is implementation that should not be changed. As I told you, if you want to prevent inheritance of that method or overriding of that method, you can make your method as final. You can declare a class as final. That totally prevents the class from being inherited. You cannot subclass it. This is particularly useful when creating immutable class like string class. Alright. If you want to have final methods, hello? Yeah. So I think this is a logical way for our
between final.
Sorry, come again.
What is the difference between final and static?
Static is class. I spoke a lot about that, right? It is about the class. It is about class members. Fine. But final is actually a keyword which is used for making things final with respect to your members. Final keyword has three uses. Understand this. Final has three uses. If you make a member as, let me write it here. If a variable is final, it becomes a constant. Alright. If a method is final, it cannot be inherited. It cannot be overridden, in fact. And if a class is final, it cannot be inherited. Fine. So final keyword has these three uses. And static is obviously static. We spoke a lot about that. Did I answer your question?
Actually, I joined late, so I did not understand what is a static.
So please watch the recording once I share it.
Okay.
And after that, you can ask me if you have any questions.
Okay.
All right. So this is a logical end for our discussion here. We have discussed about these object-oriented principles since yesterday. We have seen what object is, what method is, what class is, what variable is, and all. And today we have discussed about the static part, that your class members, you can have static variables, you can have static methods, and static is owned by the class, not by objects. And objects can access static data, but they will not own it. And there is only one copy of that data, which is with the class. All right. So that's all for the discussion. We'll continue with what abstract classes are and what abstract methods are tomorrow. This will start about a fresh topic again. So that's all from my side for the day. So do I have any questions to answer? Just go through this recording once, and if you have any questions, you can just reach me. Thank you.